In this video, we'll be reviewing the definition of sine and cos from the unit circle, and we'll be using that definition to determine what the graph of sine looks like. So here I've drawn the unit circle, that is the circle centered at the origin with a radius 1, and I can adjust the angle at the center of the circle using this slider. Okay, so for example, if I put this slider so that the angle is pi on 4, we can see that angle's been made here. And remember, by our definition, the coordinates of this point are given by cos of that angle and sine of that angle. Now, for the moment, we're just going to be thinking about sine. So sine is the y coordinate of this point here, and it's represented by the distance of that point from the x-axis that I've got in blue here, and that distance is written here. So as that angle changes, we can see that sine theta, the height of that point varies as well. And it's going to vary from 0, so if it's down here the height is 0, sine of 0 is going to be 0, up to a maximum value of 1 that we get at pi on 2. Okay, so this is as long as that distance can possibly be. If I can continue around, you'll remember that that continues to vary. In this quadrant here, we still get positive values because we're above the x-axis. If we come around to the third quadrant, though, we start to get negative values because this point has a y-coordinate below the x-axis, and so on back around to the fourth quadrant. Okay, so that's the definition of sine. What I'm going to do now is I'm going to make a second graph that does a couple of things. So you'll notice in this window on the right-hand side, things have worked out a little bit differently. On the y-axis, I still have regular numbers, but along the x-axis, you'll notice I'll have multiples of pi. Now, what I've done here is I've taken this angle at the center, and instead of drawing it in the center here, I've stretched it along the x-axis. So an angle of 0 is represented by here on the x-axis. If I take this thing to pi on 2, 0.5 pi, that's represented by this point here. Now, the point that I've got plotted here is taking its x-coordinate by the particular angle at any time, and it's taking its y-coordinate by the value of sine. So if we pick a value, let's go pi on 4, we can see that this point has an x-coordinate at pi on 4, and sine for this value is about 0.71. You can see that this point has a height of about 0.71. Similarly, if I bring this along to pi on 2, we can see, yep, it's got an x-coordinate of pi on 2, its height is 1, that's the value of sine. And so on, going through. Now, what I'm going to do now is I'm just going to show the trace for this point. Now the trace, not the label, the trace. The trace allows us to just keep points graphed as this point moves. So it'll leave a trail of points behind it. And we'll just have a look at the shape of the graph that we get. So you can see it's making a trail there. If I rotate this through a full circle, so there's an angle of pi, sine is 0, so we're back on the x-axis. I'm going to keep this going. Okay, we start to see a particular pattern emerge. Okay, we get this nice even wave-like curve. And this is what the graph of sine x looks like. And in fact, I'm going to sketch it here. By typing it in the bottom here, we can see that this is the shape of the curve. Now you notice that this curve doesn't just stop between 0 and 2 pi, it continues on. And that's because if I was able to keep this angle going, the angle would be bigger than a rotation, but this point would continue to go through the same pattern as it went around. So this curve would continue to just oscillate between these values. And this is the graph of y equals sine